Alrighty. So 3.6 mathematical models, and we're building functions. So a lot of 3.6 kind of goes back to chapter 2 and 4. You're going to see a lot of things that resemble stuff from chapter 2 and chapter 4. So 3.6, I bet when you looked at it, you were like, heck no. But when we break it down, it's very reminiscent of chapter 2 and chapter 4. So it's kind of everything coming together so far in 3.6. So let's finding the distance from the origin to a point on a graph. So let p equals xy be a point on the graph of y equals x squared minus 1. Let's express the distance d from point P to the origin as a function of x. What is d if x is 0? And what is d if x is square root of 2 over 2? So first things first, we need to express the distance d from P to the origin as a function of x. Nothing right now and anything in example 1 makes sense, but that's okay. I know what distance means. And I'm speaking as the student. Like distance, I know what that means. It means d equals x2 minus x1 squared plus y2 minus y1 squared. That we do know for sure. So at least we have that going for us. And within part A, we actually know one other thing in part A. We know origin. We know that the origin, that actually stands for 0, 0. Because that's what the origin is. It's the middle. It's where 0, 0 meets. So I have a formula and I have points. We usually plug points into formulas. That's what we're going to do. This is 0, 0, and it's the first x and y we found. So that's why it's x1, y1. So let's plug it in. Let's see what happens when we plug it in. So we have distance equals, I don't need x2 anymore because that is no longer going to be an x. So let's plug in our point of 0, 0. And we know it's a point because it says origin. And here we simplify. So x minus 0 squared is just x squared. Y minus 0 squared is just y squared. So based off of those two things, now we're here at d equals x squared plus y squared, the square root of that. Now what do we do? Now, where do I go from here? Well, let's see what else is given. They give us p equals xy. Good for them. That doesn't mean anything to me. But it tells me that it's on a graph of y equals x squared minus 1. We have two equations, and we need to find the distance model that represents this equation. So what do we usually do when we have two equations? Well, we usually plug it in. And we're going to plug it in because this is saying we want the distance of whatever's happening that has to do with this graph of x squared minus 1. So that's why we plug x squared minus 1 into distance, because we want the distance of it. Just like when we plugged perimeter into area, because we wanted the area, just like we plugged demand into revenue because we wanted revenue. So let's plug it in. We have distance equals x squared plus blank squared. And in that blank, we're putting in x squared minus 1. Now we simplify. So don't forget that x squared minus 1 squared is actually x squared minus 1, x squared minus 1. Write it out. Do you know how many times I see people mess up, including this class, where they don't write it out and they mess up foiling? Write it out. Unless you are really good at foiling, write it out twice, so then you don't mess up. All right, so let's go ahead and foil. I'm not going to show you how to foil, but I'll show you how I foil when they're the same. So since they are the same, you can foil in your head. So x squared, that's x to the 4th. X squared, that's negative 2x's, 2x squares. Negative 1 times negative 1 is positive 1. If not, just FOIL normally, but you know how to FOIL. That's not my job to teach you. All right, so we FOIL, and then let's see what else we can do. Let's see if we can combine like terms anywhere. We can, because these are x squares. Since those are x squares, we can combine them. So we have x to the fourth minus x squared plus 1. It becomes minus x squared because we have positive 1x squared minus 2x squared, which becomes negative 1x squared. The only thing that we're missing, and yes, you will be marked half off if you don't do this. It says d of x. So we need to switch this to d of x. And yes, I will mark you half off because up until this point, I've been very lenient on that for 2 tests. But I told you at one point I'm going to start caring. This is where I start caring. Why is that? Half of math is just reading directions. Reading comprehension. Half of it is just reading directions. So if you read this part A and you didn't get d of x out of it, that tells me you didn't read the directions properly. So you have to make sure when you're reading, you be careful of those words like d of x, f of x, v of t, all of those, because that's going to tell me how we're supposed to write our answer. Alrighty, what are your questions for me about part A? Yep, that's all that part A was asking.
Wait, where did it say d of x?
It's underlined in like that mint colored blank, blah, 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 blah of x.
Oh, okay.
Yeah, right here. It's d of x. There it is.
Oh, okay. Thank
So you got to
you.
be real careful when you read it. So how do I make sure I don't mess that up? I go back, reread it, and make sure they don't want that. Anytime they say express, usually they're going to have you do v of x, f of x, blah, blah, blah of x.
Mm. Okay.
Yeah.
Thank
So if you see that word, just be careful.
Okay.
Yeah.
Cool.
Cool. Good question. All right. What other questions y'all have for me? So what do I mean by questions? Because sometimes they're hard to come up with, right? You're like, that's so open-ended. I don't know what to ask. Well, what do I mean by that is, do you understand where we got origin from? Do you understand where we got distance formula from? Do you understand why we plugged in 0, 0, then why we plugged in y equals x squared minus 1?
I
That's
kind
what
of
I'm.
I kind of don't understand why we plugged in the y equals x squared minus 1.
Gotcha. So it's saying that we have this point that's on the graph of x squared minus 1. So what we're actually trying to do is express the distance from the point to the origin on this graph. So if we're using this graph, that's why we plug in the equation for the graph that this distance is expressing.
Okay.
That's a good question. Thank you, Heidi. Stellar questions already. Really proud of you guys. You ask such thought-provoking questions on my end, which is great. All right, what other awesome questions you have for me? Okie dokie. Let's keep going to B. So B is, what is D if x is 0? So we have x of 0, and then it wants the distance of that. So we're going to plug it into our model that we just found. So let's plug it in. After we plug it in, I'll draw a picture to show you what we just did. You don't have to draw the picture at all, but I'm going to show you with the picture what we're finding. So let's plug in 0. We have blank to the fourth plus blank squared plus 1. And in that blank, we're plugging in 0. So 0 to the fourth is just 0. 0 squared is just 0. So we're left with 1. The square root of 1 is just 1. So 1 unit. So let me just draw what we just found. You don't have to draw this at all, but I'm just drawing it for us so you can visualize what we're finding. So the formula we found, the model, is a model that expresses the distance from the from the origin to any point on this graph. So I can find the distance here, anywhere on this graph. Any point on this graph, I can actually find that distance from the origin to the graph. So if I want to find this distance right here, I can figure out what x that is and find how far this actually is. Or if I wanted to find it right here, I can figure out using the formula how far it is from the origin. Why is that so important? It's actually super important because that's how we do things talking about the Earth. The Earth, the equator, is the origin. And then the outsides of the Earth, that's the crust of the Earth. So how you satellites, all of that is all revolving around what we just did. This is the basics of what they do. So for those of you wondering, what the heck are we doing? This is what we're doing. We're finding the distance of any point on the graph from the origin, the direct distance. That was the formula we just found. Alrighty. What are your questions on part B for me?
My question goes back to part A. So if the point wasn't given, would we just stop at, square root x squared plus y squared? Would
Oh
that,
no, it's always going to be given.
okay.
Yeah, so that it'll never come up with like you're not given a point or an equation. You'll always be given an equation and a point. Like always. I've never seen it without it because that's what we're asking you to do. Yeah. Good question. You're like, what do I do if it looks like this? That's good. All right, what other questions y'all have for me about A or B? All right, let's do part C. So part C, we're doing the same thing as B, except now with square root of 2 over 2. This is very reminiscent of higher level math right here, this part C. So we're going to plug it into our handy dandy new distance model that we found. So we have blank to the fourth plus blank squared minus, sorry, I messed that up. That's supposed to be minus. It doesn't matter for 0. There we go. And then plus 1. Now in that blank, we're putting in square root of 2. I need to write that a little bigger. Square root of 2 over 2. So this is where we're at. We need to know what's the distance when x is square root of 2 over 2. Well, let's find it. When you get to trig, if you're going to trig, I hope you remember part C. I hope you think of me because this example is so trig it hurts. But I hope you are like, all right, I'm glad I saw this. It makes sense now. This is super trig. All right, we have to do square root of 2 over 2 to the fourth. That's a lot. So we're gonna bring this out and work with it by itself. So square root of 2 over 2 to the fourth is technically square root of 2 over 2, square root of 2 over 2, square root of 2 over 2, square root of 2 over 2. Because it's written 4 times. Now we're gonna work with it piece by piece. So we're gonna put pairs together. So I'm gonna put these together and then these together. Because whatever I get for the left, I get for the right because they're the same thing. So we multiply straight across. Square root of 2 times square root of 2 is square root of 4. The square root of 4 is 2. 2 times 2, we get 4. So I'm not going to even simplify. You'll see right now, I don't even care about simplifying. So what do we get? I know you're going to simplify. So let's just simplify. I know, I changed my mind. We're going to do 1/2. So if I got 2/4, which is just 1/2 for one pair, isn't this just going to be 1/2? That's why I grouped it into pairs. So then 1/2 times 1/2, we get 1/4. So square root of 2 over 2 to the 4th power actually simplifies down to 1/4. This is why since day one, I've always preached, pay attention to what you've already done. We already did the first pair, so we already know the second pair. And if we already did this, isn't that just square root of 2 over 2 squared because it's 2 of them? We know when it's just 2 of them, we get 1/2. And then it's all plus 1. That's why, I mean, I say it a lot, but this is a big reason why I say pay attention to what you've already been doing. From here, we need to add and combine like terms. That we know how to do. We'll get to it in a second. But what are your questions on what we did just now?
So I plugged it into the calculator and just got 0.25. Could I not do that?
Nope. Does it say to round or approximate anywhere?
Uh,
See, I'm glad you did it though. I'm glad you did it because what if someone did that? Because I never bring that up. No one ever brings that up. So it didn't say to round anywhere or approximate. So we have to use real numbers, and real numbers are with fractions and radicals.
It was
Decimals aren't
easier.
real. I know it's so much easier, but we need real exact numbers. Why do we use exact numbers and not decimals? Because if you are even 0.001 off, your whole rocket can blow up. Your building can collapse. The person can die from overdosage or underdosage. That's why we use fractions and not decimals all the time. So thank you for bringing that up. Oh yeah, go ahead, Keely.
So the 1/4 is the 4th because we did the 2 squared over 2 4 times from the exponent.
Yes.
And then the 1/2 is because we did just the 2 squared over 2 makes it 1/2.
Yes.
Thank you.
Perfect. You're welcome. All right. Man, y'all always surprise me every day. You guys you do so well. Your questions are so awesome. I really look forward to this class. I hope you know that. All right. Let's simplify now. So we need to simplify inside of our radical. That means we need everything to have the same denominator. So everything to have the same denominator, let's make it 4. So we have 1/4, and then this we multiply by 2. So we have minus 2/4. And then for 1, since the denominator is 4, it's just 4/4. Because 4/4 is 1. So we have 1 minus 2, that's -1. -1 plus 4, we get 3. So we have now 3/4. Whenever you have a radical over a whole fraction, separate it. So we have square root of 3, square root of 4, which comes out to square root of 3/2. Some of you might remember all the way back in chapter 2.4, I showed you something called the unit circle. And then I showed you that all of the values are square root of 2/2, square root of 3/2, and also 1/2. You notice that those are the X and Y value we got, square root of 3/2. That's extra information. You don't need to know any of that. But you see how it correlates back to the unit circle? The unit circle is all of calculus. What's really good about this example is what we did in orange. That square root part, that's really important because that's where people mess up in calculus. They mess up on stuff like this. They mess up on algebra. All right, what are your questions about A, B, or C? Anything we've done so far? What do you got for me?
Where did the 4/4 come from?
It came from 1. So since they all need to be 4 denominator, when you have 1, it's just the denominator over itself.
Okay, okay.
Another question.
What's up?
Why does it have to be 4? Why couldn't it be 2? Because 4 is greater than 2?
Yes, you always have to go with the bigger denominator.
Okay, thank you.
Good question. Yeah, thank you for asking. What else you got for me?
Wait, how's it a positive 3, 4? Because like, you know, when you're subtracting 1 from 2, wouldn't it be like, you know, negative?
Yeah, so 1 minus 2 is -1, and then -1 plus 4. That's how we get 3.
Oh,
Yeah,
oh, okay. I forgot
yeah.
that.
So for that, it's a little, even for me, I use a calculator. Just plug the tops into your calculator so you don't mess up on that. Because I do too, because I get my symbols all messed up in my head. What other awesome questions you have for me before we go on to example 2?
This is only gonna be one question on the test, right?
I honestly can't remember. I make so many tests. I honestly can't remember. Whatever's on the review is on the test. I can tell you that.
Okay.
Yeah, so if you have multiple of these on the review, then you'll have multiple on the test. But I honestly can't remember how many I put on there.
If there's multiple of these, you are not my favorite teacher anymore.
You're so funny. So should I go back and look now? All right. I know, Kevin, like, wow, just really throwing it out there. Savage. All right, let's keep going to part or example 2. I honestly don't think I would put multiple ones because it's just it's a lot. Oh, and I know for sure, like I'm 90% sure I didn't put anything like C. I'm 90% sure. I'm already starting to prepare for next semester. That's why it's all jumbled up in my head. All right, example 2. You might remember this from chapter 2, 2.1. You might remember something like this. It's very similar to it, a little different, but super, super similar. Let's suppose 2 planes flying at the same altitude are headed towards each other. That's the difference. They're not headed apart now, they're headed towards each other. In chapter 2, the car and truck were going away from each other. One plane is flying due south at a ground speed of 400 miles per hour and is 600 miles from the potential intersection point of the planes. The other plane is flying due west with a ground speed of 250 miles per hour and is 40 miles from the potential intersection of the planes. Build a model that expresses the distance d between the planes as a function of time t. So it wants us to build a model that expresses, you see that word expresses, so we have to be careful with the blank of blank. So it wants to express distance. We know the distance formula. All right, we have that going for us. We know the distance formula. So now let's start bringing out all of our information about our planes. So we have 2 planes. So we'll say plane 1 and plane 2. Real technical terms there. All right, so our one plane, we're not going to even draw it this time. We're just going to go straight for it. One plane is going south at a ground speed of 400 miles per hour. So 400 miles per hour, and is 600 miles from intersection. The other plane is going west at 250 miles per hour and is 400 miles from the intersection. This time they're going together. They're headed towards each other. So at the end of wherever they're going, they'll eventually end towards each other. This is what plane traffic controllers do all the time, but they do it in their head in like a second. Not even a second, like half a second. This is what they're doing. They're looking at it, then they're calculating in their head how far they are, how fast they're going, the wind speed, and then putting it into their head and coming up with how far are they and when are they going to cross paths. This is what they do every day. That's why their job, they retire at like 35 because it's super, super, super stressful. Could you imagine? Because you're like, lives are on your hands, it's super stressful. Like in Breaking Bad, if you've seen Breaking Bad, that part where the, planes collide because the dude is super stressed about his kid, right? Like that's what they're doing every day. This is what they're doing. Super intense work. They make a lot of money though, but I don't know if it's worth the stress. Anyways, so they're coming together. Keep that in mind. Together, together. So remember we said miles per hour, that just represents time because miles per hour is a unit of time. So we have 400 T and then we have 250 T. So this is what I mean by together. You see how we have two things with miles per hour and two things with just normal miles? This is X1, Y1, X2, Y2. Because it's together, because it's intersection, because they're headed towards each other, since they're headed towards each other, we're going to group like things because together towards each other means one. So if we separated these points into X1, Y1, we have X1 is 400 T. Then we have Y1 is 250 T. And then we have X2. X2 is 600. And X1 is 400. Sorry, Y2. So you see how we grouped the things that are together, that are alike together? Anything with time went together, anything with miles went together because they're headed towards each other, and towards each other means together. Now we have our X1, Y1, X2, Y2. The problem itself is very similar, not exact, but very similar because they're going together and not away. So pay attention to the words that it's really telling you. What does headed towards each other mean? That means coming together. So that's why we group things together. Now we just have to plug it into our handy dandy distance formula. But before we do that, because we're so good at plugging stuff in, what are your questions for me?
Where did the T come from?
Miles per hour.
Oh,
Yeah, that's just something that we know now that MPH always stands for time because it's a unit of time. Good questions. What else you got for me? Also, on that question, MPH is always going to be T, or like meters per second. Anytime it has distance per time, it's always going to be blank T. All right, let's plug it in. So we have distance equals blank minus blank squared plus blank minus blank squared. And in that first blank, we're going to plug in x2. So x2 is represented by 600. x1 is represented by 400t. Then we have y2, which is represented by 400. And y1, which is represented by 250t. You see how the colors come back together? Because they're headed towards each other. That's why like I kept saying together, 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 because at the end, they'll come back together. So the only thing we need to be careful of is that it says d of t. So d of t equals 600 minus 400t plus 400 minus 250t. And that's it. So you remember last time we had to simplify? Let me just tell you why we don't simplify here by showing you the other one. So remember the other one, how we had 0 in there? That's why we simplified, because we were left with just t. That's why we actually squared it and simplified it, because everything looked the same. But if we go back to what we're doing right now, there's no 0. So you could foil it, but it's harder to foil and work with. This is actually simple. I forgot the squared. This is simplified. It's simplified because squaring it will do nothing for us. So we're done. That's it. What
Do
are
you
your
mind
questions?
Do you mind showing that other example again?
Oh
please?
yeah,
Which one was that on?
2.1.
Okay.
And again, we simplified here because it ended up with zeros and it went away and we were left with just t. That's why we simplified. But on the one we just did for 3.6, is it okay if I switch away?
I don't see the
Oh,
the bottom of it actually.
That's the whole problem, I think. Yeah.
Okay, I'm good. Thank you.
Okay. Yeah. And then when we did in 3.6, there's no zeros left over and we have numbers and variables. So since we have numbers and variables, you could FOIL and combine like terms, but that's harder to work with. If I had a time, it's easier to plug it in this formula than if it were FOILed. Remember, mathematicians, we don't want to write a lot. We don't want to do more than what we have to. So by multiplying it out, that's just more work for us. That doesn't make sense. Just keep in your mind the word together. That's why we grouped MPH with MPH and miles with miles. All right. What other questions you got for me about example 2? All right, let's do example 3. All right, example 3. A rectangle has a corner in quadrant 1 on the graph of y equals 25 minus x squared. Another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis. We're going to draw the figure. You don't have to do that for the test, but I am drawing the figure because we should practice. We're going to express the area A of the rectangle as a function of x. You see that word express, so be careful with our notation. And then we're going to figure out what the domain of A is. So you see how it like kind of goes back to chapter 4 a little bit. We're trying to find the area function, right? All right, let's draw our figure. So we are in quadrant 1. That's why I'm only drawing quadrant 1. Okay. Now it has a corner in quadrant 1. That doesn't really make so much sense to me, so let's just ignore that for a second. It has a corner at the origin. I know it's misspelled. Origin means 0, 0. So we actually have one of our points is at 0, 0. Then we have another corner on the positive y-axis. Positive y-axis means 0, y. So whatever it is, it's right here or somewhere, and it's 0, y. A fourth on the positive x-axis. So positive x-axis, that could be here, anywhere on the positive x-axis, and that's represented by x0. It says we have a rectangle, and it has a corner in quadrant 1. So if I have a rectangle, doesn't it make sense to kind of like put it right here to create the rectangle? And we don't know what that is, but we know it's positive x, positive y. They're both positive because we're working in quadrant 1. And we can connect the dots to make our rectangle. We're almost done drawing, not completely yet. We're missing one thing. This says a rectangle has a corner in quadrant 1 on the graph of y equals 25 minus x squared. Our information is on the graph of 25 minus x squared. So that tells me I have to figure out something here. It says to draw the figure. Draw the figure means graph it. So we're going to graph 25 minus x squared only in quadrant 1. So first things first, let's rewrite this. We like x squared first. We're not allowed to have negative x squared. So we take it out. We're left with negative times x squared minus 25. We can factor this because it's a difference of squares. So we actually can graph this because we have an x-intercept and a y-intercept. We don't need the vertex here. Our y-intercept, your y-intercept, remember, it's always the number. So it's 25. So 0, 25. Our x-intercepts that we have, it's always opposite what's in here. So positive 5, negative 5. But we're working in quadrant 1. Quadrant 1 has 0 negative numbers. It's all positive. So negative 5 doesn't exist in quadrant 1. So if we were to graph this, it starts at 25, which is up here, and the x's go all the way to 5. There's our figure. It says the rectangle has a corner on the graph. You see how the corner is on the graph, only that one corner?
Is the corner the vertex?
No, we are not doing vertex at all with this, thankfully.
Okay, well, I
Yeah.
think on the review there was a question like this, but it said vertex.
I'm pulling it up right now. I need to double check that.
Yeah, I think it's number 2.
Yep, I found it. Yeah. Oh no, it's just saying it has one vertex. That's all. It's just another way to saying that you have a quadratic there. So you would actually do it, you would approach it the same exact way, and that's just a word to try and throw you off.
Okay, it
Yeah, so
did.
treat it the same exact way. Yeah. But yeah, that was supposed to throw you off, and it did. Good. That was my that was my goal. I do try to throw you off a little bit, but that's just one of them. Let me see if on the test, let's see if I change the wording. I sometimes do. Chapter 3, there it is. I'm pulling it up. Give me 1 second. Yeah, it's the same exact wording for the test. All right. Okay, we drew the figure. What are your questions about drawing the figure? You don't have to draw the figure for the test. It's not, I'm not asking you at all, but this does come back in pre-calc and trig and calculus. So that's why we practice drawing it now. But what are your questions about drawing it? What do you got for me?
Why did we cross out the -5?
Because we're in quadrant 1, and quadrant 1, X and Y are positive.
Okay.
Yeah, so -5, that doesn't exist in this example because we're only in Q1. So when you factor it for the test, only take the positive factor, not the negative factor. Because we're in Q1. If we were in Q2, you would take the negative one, not the positive one. If you were in Q3, you would take the negative. If you were in Q4, you would take the positive. That leads me to a really good point. Knowing whether X or Y is positive and negative in each quadrant is super duper duper important. Knowing this is very important. Knowing which quadrant gives you what kind of answers is so important. Believe it or not, a lot of people mess up in calculus because they don't even know that. They don't know that one key thing about which quadrant has positive and negative numbers. All right, let's go to B.
Wait,
Oh, sorry.
wait. How do we know where to put the 5?
Oh, we just put it somewhere. We know it's going to be not in the rectangle, so we just put it off to the right.
Oh, okay.
Yeah, we're just creating the graph for ourselves. Good
So
question.
the official answer, it's still for the x-intercept, it's still 5, -5, but you're just crossing it out, right? Or
Yeah, we just crossed it out because we're in quadrant 1.
yeah. Or is it just 5 by itself?
Well,
Like,
technically speaking, this does have 2 intercepts, but we don't care about this one because quadrant 1, X has to be positive.
mm,
Since it has to be positive, that's why we only care about positive 5.
mm. So it is for the official answer just 5, right?
Just officially for this, yes.
Oh, okay.
Yeah.
All right.
All right. Let's keep going. B. Express the area A of the rectangle as a function of X. So area stands for X, Y. We're also given another equation. We're also given Y equals -x² plus 25. It says it wants us to express the area of the rectangle. So that's why we use the equation that this rectangle touches. So if we want area, we're going to plug this into area. Just like when we did perimeter and area, that question from chapter 4, how we plugged perimeter into area because that's what it wants. It wants area. That's why we plug it into area. So when we plug it in, we have area equals x times y, which is negative x squared plus 25. We distribute. So now we have a of x equals negative x cubed plus 25x. And we say a of x because it says a of x. And how did I know to be careful about that? It says to express. Anytime you see express, be careful with your notation. So what we found was a model that represents the area in here. Other than numbers looking a little different for part B, part A, that's so new. But part B, we kind of have a good foundation on that already. Which is great because now like you already kind of know what we're doing in B. So it kind of leads you to like what's still getting you, what's still stumping you. What are your questions for part B? Alrighty, let's go to part C, domain. I'm gonna show you two ways to think about domain of area of this function we found. If you draw it, the domain is already there. If you don't draw it, don't worry, we'll still get to that. We drew it. The domain is on this page. The domain, remember, that's what X can and cannot be. Does anyone want to take a shot and tell me what domain is? Oh, sorry, I just saw Keely. No, we'll never have to evaluate for part B. We will always stop there, Keely. Good question. That's the important question.
Is it 0, 5?
It is 0, 5. It is 0, 5. Yep, our domain is already there because this chart, this figure only goes from 0 to 5. That's why it's 0, 5. Kevin, yeah, good job. Now, what if we don't have the figure? How do we find it? We can still find it. So, and it's parentheses because at that point, nothing's happening. It's just a point. Nothing's happening at that point. So that's why they're parentheses. But let's say we don't have a figure. Let's figure out how do we do this. So right now we're in Q1. We're only working in Q1. So Q1 states that X has to be greater than 0 and Y has to be greater than 0. Right now, we don't have an equation for X. We have an equation for Y though. We do. We have an equation for Y. Y was represented by that function 25 minus X squared, which we rewrote. So we need to know what makes this function greater than 0. Why greater than 0? Because we're working in quadrant 1, and quadrant 1 states your function has to be greater than 0. So our function of negative x squared plus 25, it needs to be greater than 0. So we can solve for this. I'll subtract 25. So we get negative x squared is greater than negative 25. Divide the negative 1 out. So we're left with x squared is now less than positive 25. We square root it to get x by itself. So we get x is less than positive negative 5. But since we're in Q1, x has to be less than positive 5. And it's 0 to 5 because Q1 starts at 0. If you wanted to write this in set notation, it's x such that 0 is less than x and x is less than 5.